And today, I want to finish up with other points of view on what a derivative is. So this is extremely important. It's almost the most important thing I'll be saying in the class, but you'll have to think about it again when you start over and start using calculus in the real world. So again, we're talking about what is a derivative. And this is just a continuation of last time. So as I said last time, we talked about geometric interpretations. And today, what we're going to talk about is rate of change as an interpretation of the derivative. So remember, we drew graphs of functions, y equals f of x, and we kept track of the change in x, and here the change in y, let's say. And then, from this new point of view, a rate of change, keeping track of the rate of change of x and the rate of change of y, it's the relative rate of change we're interested in, and that's delta y over delta x. And that has another interpretation. This is the average change. Now, usually we would think of that if x were measuring time, and so the average, and that's when this becomes a rate, and the average is over the time interval delta x. And then the limiting value is denoted dy dx, and that is so this one is the average rate of change, and this one is the instantaneous rate. Okay, so that's the point of view that I'd like to discuss now and give you just a couple of examples. So let's see. Well, first of all, so maybe some examples from physics here. So Q is usually the name for a charge. And then dq dt is what's known as current. So that's one physical example. A second example, which is probably the most tangible one, is we could denote the letter s by distance, and then the rate of change is what we call speed. So those are the two typical examples, and I want to illustrate the second example in a little bit more detail, because I think it's important to have some visceral sense of this notion of instantaneous speed.